let's try to solve this example. If you can see here, this is the Euler equation because you have a coefficient in term of variable where your coefficient, the first coefficient is 1x squared, the second one is negative x, and the third one is 1y. Okay, so to solve Euler equation, the first thing you need to do is you need to change, or you need to transform this Euler equation into general form of your second order ordinary differential equations. So we need to know what is the value of a. So here a is equal to 1, b is equal to negative 1, and c is equal to 1. Okay, after we know the value of a, b, and c, we will substitute it in the general form, where the general form is a times d square y dt square. So a is 1 times d square y dt square plus b minus a. So your b is negative 1 minus with a is 1 dy dt plus c times y. So your c is 1 times y is y, equal to, for the right hand side, don't forget that you need to replace x by exponent t. So you have exponent t power of 3 up here. Okay, so now we expand this equation, you will get d square y dt square minus 2 dy over dt plus y equal to exponent 3t. Okay, so now from Euler equation, you already have a general form of second order ODE that we can choose any method to solve this equation. Okay, but then first of all, we need to recognize whether this is homogeneous or non-homogeneous. And if you can see here, your fx is not equal to 0, so this one is non-homogeneous. Okay, so when this one is non-homogeneous, you can choose whether to use undetermined coefficient method or a variation of parameter method if it's not mentioned to you. Okay, so first of all, we need to solve the homogeneous part first. So we take the homogeneous part here. Okay, so we have d square y over dt square minus 2 dy over dt plus y equal to 0. This one is homogeneous part. Okay, we need to write the characteristic equation. So the characteristic equation for this one is lambda square minus 2 lambda plus 1 equal to 0. Okay, so your value of a here is 1, your value of b here is negative 2, and your value of c here is 1. Okay, so next you need to check your case. So b square minus 4ac. So you will have b is negative 2 square minus 4 times a times c. Okay, so you will have 4 times 4 is equal to 0. So this case falls in the second case where you have lambda 1 is equal to lambda 2. So you can choose whether you want to factorize manually or by using calculator. So factorize your quadratic equation here, you will get lambda minus 1. Okay, so your lambda 1 is equal to lambda 2 equal to 1. Okay, so that for this case, your general solution yc will be exponent lambda times x. So your lambda is 1 times x is x, a plus bx. So this is your yc. Okay, so now we move to solve the fx. So we need I choose to use undetermined coefficient here. Okay, so to solve fx, we have our fx equal to exponent 3t. So this exponent 3t, I compare it with cx to the power of n exponent rx. So your c here is 1, your x here is to the power of 0 because x to the power of 0 is 1. You cannot see any x here, right? Okay, then you have exponent 3t here. Before that, because we are using the derivative dy dt, so our solution here is in terms of t. Okay, sorry. So we have et plus bt. Okay. So now your x is t. Okay. So by comparing this term, you will get the value of n is equal to 0, the value of r is equal to 3, and because of r is not equal to any lambda here, so your value of s equal to 0. Okay, so now you want to find what is your yp. The general form of yp is equal to x to the power of s, okay, an xn plus until a naught, okay, exponent rx. So now you already have your value of s, so x to the power of 0, your n is equal to 0, so you just have a naught inside here, and you have exponent 3t. Okay, so your yp is x to the power of 0 is 1, so you only have yp is a naught exponent 3t. Okay, so now you need to find the first derivative of yp, so you need to find what is the yp prime. So your yp prime is 3 a naught e3t, and you also need to find what is your yp double prime. So your yp double prime is 9 a naught e3t. Okay, so you need to substitute all yp, yp prime, and yp double prime inside this equation. Okay, inside this equation. Okay, so you have double derivative there, so your yp double prime is 9 a naught exponent 3t minus with 2 times first derivative, so your first derivative of yp is 3 a naught e3t plus y, so your y is a naught e3t equal to e3t. Okay, so expand the equation, you will have 9 a naught e3t minus 6 a naught e3t plus a naught e3t equal to e3t. Okay, so solve this equation, you will have 9 minus 6 is 3, 3 plus 1 is 4, so you will have 4 a naught e3t equal to e3t. Okay, so if we compare left hand side and right hand side, we can eliminate e3t and e3t, so you will have 4 a naught equal to 1, so your a naught equal to 1 over 4. Okay, so you already have your value of a naught equal to 1 over 4. So now you know what is your yp. Your yp here written as a naught e3t. So you already know the value of a naught. So our yp is 1 over 4 e3t. Okay, so now the solution of your second order homogeneous differential equation is y equal to yc plus yp. So you already have your yc exponent t a plus bt plus with your yp 1 over 4 exponent 3t. Okay class, so this is your solution to your second order differential equations. But then don't forget, at the beginning of our solution, we are substituting our x. Okay, at the beginning of this solution, we are substituting our x with exponent t. Now we want to substitute back all t in the solution with x. So how to find t? Okay, you need to eliminate exponent, so you need to plus ln. So you will have ln et. Okay, so you add ln on the right side, you need to add ln on the left side as well. Okay, so ln and exponent is eliminate. So what you will have here, ln x is equal to, ln x is equal to t. Okay, so we will substitute all t in our solution with ln x. Okay, let's substitute. So we will have our y equal to exponent ln x a plus b ln x plus with 1 over 4 exponent 3 ln x. Okay, so you can rewrite this one to be exponent ln x a plus b ln x plus with 1 over 4 exponent ln x power 3. So the 3 here become power at the back. Okay, so now exponent and ln is eliminate, and this one also eliminate. So what will you left with is y is equal to x a plus b ln x plus 1 over 4 x to the power of 3. So this is your final solution in terms of y and x.